here. And as Aniko mentioned, my research interests go in the line with the Linguistic Linked Open Data paradigm and NLP tasks. And I'm going to make a small correction here. I'm not LLM expert. I'm just my profile is more linguistic than engineering. So I'm trying to explore how, as non-expert in LLMs, how can we make use of them and align LLMs with my research line. That would be the Linguistic Linked Open Data. So let's directly jump into the presentation. For today, we have 3 objectives. The first one is to give you an overview of what Linguistic Linked Open Data is. Well, quickly, because I assume that you already know that. And the role in natural language processing tasks. And the second objective is focused on LLMs, on only a brief overview of what LLMs are and how they work, and their benefits and their limitations. And finally, combining both, we will explore the combination of linguistic linked open data and large language models. So let's start with objective 1. And let's start by defining the problem. When performing natural language tasks, researchers and professionals face problems of data consumption, since traditionally data sources are published to be consumed by users and not by computers. And therefore, they present some limitations, especially when trying to reuse them. Some of these limitations are that commonly no standards, inner structure among resources are followed, and which hinders automatic processes over this data. Also, we can find data in different formats, such as XLS or XML, but also proprietary formats, such as PDF, that are not accessible to computers easily. This issue involves that resources are isolated and not interlinked, and consequently, they are published in different access points, which hinders their reusability. So, to solve these limitations, the linked data paradigm emerged, and amongst other benefits, we can say that the linked data pursue the publication of resources following standardized inner structure and standardized open formats, and which means that they can be easily accessed, edited, and updated, which is another problem with the traditional data sources, that they usually get outdated soon. And so following this paradigm, this linked data paradigm, resources can coexist in the same space and can be easily accessible from a single access point, since they can be interlinked. So language data publishers took advantage of these benefits, launching the initiative of the Linguistic Linked Open Data. So to publish Linguistic Linked Open Data, some specific vocabularies or ontologies or models need to be followed. Let's have a quick overview of the most common vocabularies to publish language resources depending on their typology. So for dictionaries, for instance, we have Ontolex. For thesauri, we have SCOS. For terminologies, we can follow both previous ones and also others, such as TVX in RDF and Termlex. And to perform linguistic annotations over corpora, we have OLIA. We can make use of OLIA. And to structure corpora itself, we can use the NIF standard, no? And let's see now some examples of that you already may know of language resources as linked data. So on the one hand, we have resources from the general domain, such as WordNet, BabelNet, ConceptNet, Wikidata, Wikipedia, or Divinary. And on the other hand, we have domain-specific resources, and we can find resources of very varied domains: medical, legal, I don't know, sports. But here I have selected some from the legal domain that I have been using during these years, such as the UNESCO Thesaurus or the STW or Thesos, the International Labour Organization Thesaurus, or the well-known by everyone here, Eurobook. And these resources contain different types of data, such as, for instance, translations, synonyms, definitions, hierarchical relations, and other terminological and lexicographical data that can be very useful for natural language processing. Let's have a look at an example from BabelNet of what entry in a resource published as linked data looks like. So here, for instance, we have the employment contract concept. And it has a definition attached: contract between employer and employee. And inside this definition, we have the main components of what a contract is. We have contract, employer, and employee. And when we talk about interlinked data, so these are terms that are linked and you can easily access from one to another. Below, we have other definitions from other resources, such as Wikipedia, Wikidata, and Wiktionary. And this is another benefit of the linked data, that we can easily aggregate data from different data sources. It is also common in entries from linked data resources to find inner links and external links. For instance, for this term, employment contract, we can also find inner links to other terms, to other concepts. We already mentioned the employee and employer concept, but we can also see maybe not so direct relations, but narrower relations, such as fixed term contract of employment, that can be also useful to perform NLP tasks. And on the other hand, we have external links, which mean that this term is also present in other resources, such as the already mentioned Wikipedia, Wikidata, and Wiktionary. And this is the usefulness of linked data, that we can easily jump from one term to the other and from one resource to the other. And this is very useful when trying to automate tasks. And this is why we also say that resources published as linked data are not isolated, because they are interlinked and they can be easily aggregated. Okay, so now that we have seen the main elements that we can find in language resources as linked data, let's now comment on several experiments of traditional NLP approaches using Linguistic Linked Open Data. We have here some experiments, for instance, with WordNet for bullying detection, or with UMLS that I didn't mention before, but is a well-known thesaurus from the medical domain. And in this case, the authors use it for medical task prediction. We have also other experiments with general resources such as Wikidata and Wikipedia for QA, and also we can find experiments with Eurobook, in this case for relation extraction. And well, so within these experiments, we can find a wide variety of technologies. We can find, for instance, approaches based on rules, based on statistical models, or on vectorial models, on neural networks, convolutional or recurrent, and also lately we can see experiments based on transformers and attention mechanisms. But there is another player in the game. known by everyone, right? The large language models. And with this, we move to the second objective, to give you an overview on large language models and the benefits and limitations. Large language models are based on these two techniques I mentioned before, on the latter two techniques mentioned before, transformers and attention mechanisms. Basically, what they do is to assign probabilities over words and word sequences in broad terms. So, as an example, let's have a look at this sentence. The student opened their, and we have a set of words that can complete the sentence. That would be books, laptops, exams, and minds. And based on the training data, speaking in general terms, the LLM assigns a probability to the words, and in this case, the highest probability would be books, which is in this case would be the correct word to complete the sentence. This is, in general terms, how LLMs produce results. And just to have the big picture of current LLMs, these are the latest and the biggest that have been or are being still developed currently. And I think at this point it's interesting to see the different sizes, for instance, of the biggest. No, so for instance, if we have a look at GPT-4 from OpenAI, or Olympus from Amazon, or Gemini from Google, we can see that they are far away in the number of regarding the number of parameters from the rest of the attempts. And this is just to reflect a bit about the development of LLMs, that since the first models were launched in 2019, there has been an exponential growth, and one may wonder what's next for this 2024, right? Well, just to have a big overview of the LLMs, current LLMs that are being developed. So with this, let's move to the benefits of LLMs, also surely known by everyone. But so just have a quick look at this. LLM's benefits are, well, they are able to return results in multiple languages, and this we can easily test this. So just making a question to ChatGPT and another question in another languages, in another language and another. So if we change languages, asking ChatGPT, for instance, it will quickly return answers in other languages. So this is a well-known feature of these models. Another is that they can also be relatively easy to customize, and they are also scalable, no? Since more and more text can be added to continue training them, which leads to an improvement over the time. And they are also known to be efficient in a multiple variety of tasks. However, they present some limitations as well. The issues of hallucinations and biased results are commonly known by researchers, but we can also find a lack of accuracy, especially in the performance of smaller models, and also in the performance of large language models over small corpora. And let's stop here a moment, because the two limitations I want to mention are the same as the two benefits I mentioned before. And why is this? Because yes, LLMs can improve over the time, but the cost of retraining large language model is huge, and and not everyone can afford that. It's not realistic. And coming back to the multiple tasks, yes, they can perform multiple tasks, but they are, but only in general domains. So if we try to solve tasks in specific domains, we will get a lot of problems. So this is This is also a limitation, no? So keeping these limitations in mind, let's now see some examples of how structured knowledge can help. And with this, we move to the objective 3, to explore the possibilities of introducing structured knowledge, and specifically linguistic knowledge, in LLM processes. And for that, I'm going to show some recent works, research works, and comment them in broad terms on the technique employed just for inspiration. So let's start with inspirational work number 1, which is focused on the task entity alignment, which is the task of finding entities in two knowledge bases that may refer to the same real-world object. In this approach, authors used a domain-specific graph, and the approach to inject the knowledge in the LLM used is Graph Attention Network, and the LLM employed is ERNIE. And I wanted to show this work because here authors pay special attention to relations amongst entities. So as shown in the diagram, by creating graph embeddings, more candidate entities are added to the LLM for the subsequent entity alignment task. In the evaluation, authors state that this approach worked better than other entity alignment tasks. Okay, let's move to the second research work. And this one is very interesting because the task tackled here is natural language to Sparkle, which is self-defined, the task of translating natural language into Sparkle. And this is nowadays a very challenging task that is still not solved. And in this approach, authors include data from Wikidata and from a domain-specific knowledge graph. And the techniques used here in this work are fine-tuning and data augmentation over the LLM. Someone has the mic open and there are some noises, background noises. And I wanted to show this second inspirational work because I found it very interesting that they use this structured knowledge in 2 stages of the process. So first, in the upper pipeline, they use Wikidata to fine-tune the LLM. And it is very interesting as well because they use linguistic knowledge here. They retrieve synonyms and term variations from Wikidata to expand the instances of the questions that are going to be translated. And in the second pipeline, in the pipeline below, they use a specific domain-specific knowledge graph to augment the data set of queries that would be the result of the LLM. And in their evaluation here in this paper, authors claim that the results of this approach are better than using just the generic OpenLLM LLM itself. So I thought this was an interesting approach as well. Let's move to the third research work I wanted to mention today. And this task is a bit different because it's not pure NLP, it's a prediction task. In this case, authors want to predict, so based on a training set of clinical health records, authors want to predict the probability of mortality of patient and the probability of coming back to the hospital after a disease. And in this work, authors use a domain-specific knowledge graph. The technique employed is retrieval augmented generation, and the LLM used, I couldn't, or they don't mention in the paper, or I couldn't find it. I'm not sure. And just to mention that retrieval augmented generation technique is the one that can be seen in the middle, no? To retrieve, and it's used to retrieve contextual model to the graph and add them to the entities mentioned in the dataset. A clear example of this is the following. So we can see that in the blue box would be the training dataset, from which authors retrieve the entities low blood pressure and high blood urea nitrogen. And what they do is to match these entities from the source dataset with entities in the graph. That would be hypotension and uremia. And from the graph, they retrieve definitions of these entities that, by the way, they do this alignment by using hierarchical relations, which is also interesting. And from the graph, they retrieve definitions that then can be used, are used to give contextual knowledge to refine the language model. And I think this is also a very interesting approach. I'm going to drink a bit of water, if you don't mind. Okay, let's move to the inspirational work number 4. And in this case, the task is also a bit different. It's called node classification, which is the task of predicting the label or the category of a node in a graph. And we can call it a subtask because it's normally part of a bigger process that as a recommendation system. But I wanted to mention this approach because in this case, they use a linguistic knowledge graph to produce that is involved in the technique knowledge distillation. And in this approach, authors used several, so they compare the approach in several LLMs, Llama, Mistral, and others. But I wanted to mention this approach. I find this very interesting as well, because the knowledge here is not directly injected in the LLM, but instead they use the LLM to transfer knowledge to a smaller neural network. So basically, they add the knowledge that the LLM has plus the knowledge from the linguistic database into the LLM, the NN, the neural network that is the student. So the LLM would be the teacher and the smaller neural network would be the student. And I wanted to mention this because the main advantage of this technique is that the computational costs that we mentioned before are reduced with this technique. And finally, it says inspirational work 3, but it's the 5th already. Finally, I wanted to show another work that tests different approaches for knowledge injection. In this case, the task to solve is question answering, self-defined as well, the task in which a computer needs to process questions and answers in natural language. And in this case, authors use different knowledge injection approaches with the knowledge graph Wikidata, and the LLMs employed are ChatGPT and Vicuna. And I wanted to show this work because they test different approaches. So they try to inject the knowledge in three different stages: in the training of the LLM, in the inference, during the inference, and as prompts. And the conclusions are quite encouraging because so it seems that LLMs understand better the structured knowledge that initially thought. Okay, so but what's the point of this? So what do I wanted to communicate with this? What are the conclusions that we can extract from this broad analysis? So the first The first conclusion that I wanted to comment here is that it seems that factual knowledge is more useful for LLMs than linguistic knowledge. So we have seen during this analysis that not many linguistic resources were used. Only, if we can call it like that, only Wikidata was used. But so that it was not the general use case, right? So, and why is that? And I think this is because LLMs make great use of semantic relations and contextual knowledge. And I think so. And I think that traditionally, linguistic resources don't have this information. So if we think of a glossary, we don't usually find these elements inside. We can find maybe a small definition, a translation, but not really semantic relations and contextual and other kinds of contextual knowledge. Which leads me to the third conclusion, and is that I think that within this LLM landscape, we need to generate richer language resources and linguistic resources. So maybe traditional resources such as glossaries and taxonomies are not really useful. Maybe what we need to do is to enrich our resources with this, with the semantic relations, contextual knowledge, usage nodes, other hierarchical relations, and other domain-specific relations that can be useful for LLMs. And this is why I think that the linked data paradigm is very useful in this case, because as we saw, it can be so. Language resources as linked data provide easy access to the information, and so it's easier to access language resources and retrieve information from them to generate richer resources, right? And that's encouraging as well, no? As linked data providers. And another conclusion I wanted to extract is number 4. Well, we saw that knowledge graphs are widely used in LLMs. They are so domain-specific knowledge graphs are more used than linguistic knowledge itself. So what we could do is to use the linguistic knowledge to enrich knowledge graphs. No, not directly apply the linguistic knowledge into the LLM, but to enrich knowledge graphs that then will be afterwards injected in the LLM. And another option of using linguistic knowledge for LLMs is not directly injected in the LLMs, but around. So we have seen very complex pipelines in these works, where the LLM is just a component, but around many other tasks are performed. So maybe linguistic knowledge is useful in other stages of the process. So in the pre-process to annotate data, or in the post-process to refine the results, for instance. And finally, what I notice here, and I think this is very important, is that I still miss research works over small corpora. Usually research paper published are works on relatively big corpora. But the reality is, when we are working in international research projects where companies are involved, that we need to solve real problems on very, very small amounts of text. And we cannot find works that tackle this issue. No, normally research works are performed over huge amounts of corpora. So in some occasions, the solutions proposed by research paper are not realistic, and this is, I think, a pending issue. No, we need to work more on solving issues on small corpora. So as more general concluding remarks, I wanted to say that, well, as shown, structured knowledge still have a role to play in this LLM landscape, in this LLM craziness, no? Because we all wanted to jump into the LLM trends, and maybe we do not need to follow every trend, but we need to prove the usefulness of what we do, linked data, despite the trends. And also I wanted to remark that, for instance, when thinking about solving issues on small corpora, maybe not all issues need to be solved by LLMs. Maybe we can make use of smaller models, such as BERT or Roberta, and that's also fine. I mean, as long as we solve the problem, it's fine. So just to conclude, and in line with this last comment, I wanted to quote one researcher colleague from the ontology engineering group that said that you don't need an ocean liner to cross the Manzanares. The Manzanares is a very small river here in Madrid. So we don't need a huge ship to cross a small river. Okay, and just as an illustrative example, this is the Manzanares. This is so just for you to see that it's very small, and yes, it's like a metaphor of what I wanted to communicate here today. And that's the end of the presentation. I mean, just wanted to give you an overview of what's going on, to encourage you as linked data providers and producers that we still have a role to play in the current landscape, and we will not probably lose our jobs. And that's, thanks for listening, and I'm open to questions. Please don't post technical questions, because I'm not I'm a linguist and I don't really know about technical stuff. Thank you.
Thank you very, very much. So I already see a hand raised, and I would just first I would like to first thank you for this enlightening presentation. And I think that's our common experience with all the new trends, that everyone is afraid that we are going to lose our jobs because there is something new happening. But at the end, we just realized that they are not competitive, but complementary somehow, as you very, very well presented during the presentation. So I give the floor to the questions, and I just want to remind everyone that this session is being recorded. So I think also until the end of the questions and answers, because it can be very useful to see it also afterwards. So Lorenzo, you were the first.
Hi, hello everyone. Hi Patricia. Thank you very much for the interesting talk at Landscape. Unlike you, I am an NLP researcher who did a lot of things in linguistics, so like kind of the opposite side. And I did a lot of work on how to embedding graph like WordNet and syntactic graphs into smaller models. So how to bridge these linguistics features and knowledge graph features into the same small model. And so I have a question which is basically referring to one of your conclusion and hopes on the smaller model. So the first one would be, what do you think is right now a small data set? Because we have a lot of data sets that refer to small, small resource language is one of the crucial point of current NLP, ACL as a track for it. Lots of research are dealing with it. And what is a task that might be solved by a smaller model? Because all of our results, including, unfortunately, mine, suggest that if you go small, for example, with a knowledge graph embedding model, you are going to fail against even a small language model like BERT, because BERT is still a large language model. And so, yeah, that's my main question.
Yes, in number of, so I cannot tell you now in the size, but we experience, so I'm talking about our let's say, professional experience as a research group. Recently, we were working on the legal domain in Spain, in Spanish labor law. So it's very specific, legal domain, but Spanish labor law. So the text we had, it was like it's called in Spain, in Spanish, it's called the Estatuto de los Trabajadores, which is the worker statute. And it's a very small document, and the task we wanted to solve was relation extraction, but not over entities, but between terms to enrich resources. And we tried with BER actually. No, with BER not. It was another one. It was a larger model, and we failed. We failed. So yes, so that's the real use case that comes to mind. In this case, it's called the Estatuto. So the worker statute over and relation extraction, and that's the task we failed, and that's the one I was thinking when mentioning this in the presentation.
Thank you.
Thank you. Okay, so I see a comment from Willem in the chat. What would be useful to add to reference data, such as taxonomies, to provide or to improve context?
So during my previous research, we developed a small tool that it's called Termitap. And what it did was to extract term from a source term and enrich, so to create rich terminologies. And what we did was to enrich it with everything that could be retrieved from language resources as linked data. And so, meaning definitions are a good contextual knowledge, except definitions, usage notes that are notes that give you hints of how to use a term, context of use, and these can be retrieved from language resources and also from the source text. So it's kind of easy to retrieve this, and I think this gives a lot of information to the LLM, but not only the text, but together with the term itself. And what else? Semantic relations, not only hierarchical, as I mentioned, not only broader, narrower, but domain-specific relations. This was the task I wanted to. I was mentioning before. So what we wanted to solve before was the task of retrieving, for instance, the relation between employer and employee. Which I think it could give a lot of semantics to the LLM. And another resource that is very useful to retrieve this contextual knowledge that I was mentioning is IATE. IATE has a lot of information of how to use a term, of examples of use, and it's a pity that it's not linked data, but it can be also used for these purposes to enrich the resource. And synonymy relations are also very meaningful in the sense that it gives more context to the LLM. So they are not working only with one term, but with a lot of very, very close terms that can be useful to improve the results.
Thank you very much. So I'm going in order in the chat for the questions. So Sergio wrote or asked, what is the current state on using LLMs for entity linkings among various large-scale ontologies?
Sorry, again, please.
So what is the current state on using LLMs for entity linkings among various ontologies at a large scale?
I'm not sure. I mean, I'm reading. I could point you to some works, but I would need to look at them. Yes, because we are also working. So in our research group, we are trying to build a system, our own system on word sense disambiguation and entity linking, and we are currently performing a state of the art on that. But so not me specifically, but a colleague. So I couldn't answer. I cannot answer you now, but if you drop me an email, I can ask and give you some hints.
Thank you. And in the meantime, I see that also Lorenzo raised his hand. Maybe it was related to this question.
Yeah, no, sorry, that was a mistake.
Okay.
So just
Okay,
I
right.
wanted to, yeah, I could provide a small context to the question, but don't worry.
Okay, no problem. I think even after this meeting, you can also discuss maybe privately if if there are some contacts or email addresses, or you can put in the chat. Yeah. Okay. Then Mihai, do you want to say it yourself, or shall I just read your comment?
You can read it, no worries.
Okay, okay. So we are used to engage with smaller knowledge graphs in the form of controlled vocabularies, and larger ones like Wikidata. Somehow in line with LLM, is there a value in developing also larger controlled vocabularies, or contrary, some smaller, more specific?
I think as I conclude, as one of my conclusions that I mentioned before, I think that the key is to develop more and more so richer control vocabularies. Because the issue with the context I mentioned before, I think control vocabularies and glossaries as traditionally regarded are not that useful because they do not contain that much contextual information. And so I think the key is to work on, but that's only my personal opinion, of course. The key is to work on richer and richer resources. Yes.
Okay, thank you.
Sorry, maybe I should complement a little bit the question. It's about one thing. It's about the size in terms of numbers of entries, and another question. It's about whether should we. Because this is what was my impression after your answer. It's about the additional properties that are enriching the value of that vocabulary. So what are you referring to?
I refer
one
to
or both of them. The second.
Of course, ideally both, but I specifically refer to the second one, to adding more properties. More properties, yes.
Okay, thank you.
Thank you. Okay, any other questions? Ah, yes. Miguel, do you know of any line of research that attempts to use LLOD-based data as a benchmark to evaluate linguistic competency present in LLMs? So any line of research that would like to use linguistic linked open data? Yeah.
To evaluate you mean the linguistic correctness of LLM results?
Yeah, that's right. How well they do syntax-like, morphology-like, etc.
Well, I know not actually. What I know are ontology models that can represent that, such as Lexinfo, Lexicog, but these are models, not resources themselves. So no, I cannot answer this. Sorry.
I can point out to, if you want, to a couple of this. My part of my PhD was exactly to use knowledge graphs to evaluate the linguistic knowledge of at that time smaller model like LLM, like BERT and Roberta and stuff. So there's quite some research on, for example, leveraging WarNet and building data sets to know whether large language models without specific training know can retrieve the hierarchy. My work specifically was whether they would do it in a compositional manner. So we knew at the time that Bert and staff knew rather decently that like a pigeon is a bird. And then the question was whether they knew that the red pigeon is a red bird, but a small cat is not a small animals and stuff. In terms of morphology, there's some work from the psycholinguistics community. I would refer you probably to the work from Marelli, where they built classifiers and other like priming experiments using both large language models and smaller distributional semantics models to study both whether the models were informed about the lexical and morphological information, and whether you could use the information from the models to predict the human behavior. So basically linking the behavior of the model to the behavior of humans in morphological tasks. And I'm fairly sure that if you look at work from the people in Pisa and in Normale, they have some interesting works on sentence processing and comparing, for example, reader time and difficulty in processing with respect to humans and large language models. But my point is, it's definitely in there, and there's a lot of it which is produced by the psycholinguistics community. One other researcher, it's probably Giulia Randell. I can send you the link later, but just to give a bit of context. Sorry about that.
I would be very grateful for that, and thank you so much.
Thank you. So maybe I propose that in privately you send your contacts in the chat, and then you can continue the sharing of these research results. Thank you. So we move forward with the questions. Mihai asks, would you categorize Wikidata as a knowledge graph with enough attributes to serve the scope?
Yes, this is so, and as we saw, this is the main resource used within these experiments. However, I have some issues with Wikidata because not everything is correct. I used it in several occasions for some research works. And for instance, I have an issue with the synonymy relations in Wikidata, or synonymy. They call what they call alternative labels. So they have a concept and some alternative labels for this concept. And what I notice is that they are not really alternative labels, but narrower or broader terms. So some of the information is not really correct there. That's why I would suggest Wikidata, but with refinement somehow, because some of the content there is not very accurate. Yes, also, well, I noticed that ideally I would add more usage examples to the concept in Wikidata, because I am thinking now of some entries that they contain definitions, but they are not, they are a bit short or brief, and but they don't usually contain examples of how to use a term, or contextual examples of in which a term can be used. And this is also a shortcoming of Wikidata. I mean, ideally, so my reference terminological asset would be IATE. because of the context, so it contains a lot of information, and I think if IATE is used for LLM refinement, in my opinion, results would be quite good.
Yeah, but to add to this also, traditionally the terminology work is somehow different in terms of interpretation of what an alternative label means. Our own Eurovoc, for example, if you look in a thesauri, usually alternative label is something different than of what a knowledge expert will understand. So you are coming also from the terminology actually. So how do you see this? Is there something, a transition that has to be done in the terminology working? How do we classify labels in order to align with the knowledge management approach, or what should be the way to go?
That's a tough question because you are opening a huge field there. So there are a lot of different theories of terminology, of what terminology is. And actually, we are now discussing a model to represent terminological data in the semantic web. And we had several meetings already, and we didn't come up with any decision yet because we have very different views of what terminology is, and we cannot reach a consensus. So that's very, very difficult, I say, to answer, and I can give you an answer, but another person, another terminologist can give you another way different answer. So
No, my question was related with based on what on the scope of the research. So practically, my understanding is that there is a need to improve the terminology assets in order to support this kind of activities. That means filtering them and making them more exact in this kind of relations, let's say. But that it's getting into contradiction what traditional terminology does. So probably we have to have some kind of branches here.
yes, that's it. For instance, so in my view, synonyms are very, very useful, ¿vale? I mean, synonyms are very useful, but many terminology experts don't consider synonyms as a terminological element, because in some terminology theories, so we have a term and a meaning, and term meaning, term sense, and we don't have several terms to name the one thing. And so that's contradictory sometimes, but in this case, so for research purposes, I think they are very useful, although they cannot be considered terminological items. So yes.
Thank you.
Okay, so thank you very much. I see that Lorenzo also shared a few links in the chat, so please take a look and save it for yourself. Are there any more questions? No, so then, yeah, I would like to thank you very much for the presentation and also for the very interesting discussion and for the replies. So I think we all profited from it, and it was really useful for our work, for our interest, for our daily jobs. So thank you very much, and then see you at the next event. Yeah, thank you.
Thank you, Aniko.
Have a nice day.
Once again, thank you very much, Lorenzo.
Thank you very much.
Thank you.
Thank you very
No
much
worries.
for the
Thank
talk.
you, and thank you to Patricia. It was very